Titanium. It's only in the last few decades that we have been able to manufacture and process this metal. Today, it is one of the most important raw materials for high-tech industry. Delivery of the raw titanium. It comes from Kazakhstan or Ukraine. Many of the manufacturing processes are top secret. It's only now that Deutsche Titan GmbH in Essen has allowed us to film. Quality control. The plant manager inspects the starting material, the so-called titanium sponge. In this form, the metal is still too porous to be forged. Strict safety rules apply during production. The titanium sponge must not be wet. Otherwise, in the event of a fire, there could be a steam explosion. The weighing and mixing unit. Everything is controlled automatically by a sophisticated handling system. First, the starting material is fed into the mixing bins. Production is carried out in 3 shifts around the clock. The plant in Essen produces 30 different titanium grades. The weighing and mixing unit is capable of weighing the alloy components with extreme precision. This is needed in order to achieve the desired corrosion resistance of tensile strength in the finished alloy. These drums contain the alloying elements: molybdenum, zirconium, vanadium, aluminium or palladium. The mixture determines the properties of the metal. Titanium can be as hard as the best steel, yet weigh only half as much, an unbeatable advantage. Containers move continuously through the factory, taking their freight to the next station, the press. First, the mixer blends the titanium sponge and the alloying elements. Nothing must be spilled. The worker sweeps everything up. The gigantic oil hydraulic press compacts the titanium mixture with a pressure of 2,500 tons. Press capacity equals 7,500 tons. Even the floor of the factory shakes under these huge loads. The compact is stuck tight and has to be pressed out by the machine. Each compact is 62 centimeters long and weighs 100 kilograms. 100 of these compacts go to make an electrode, which is the basis for the subsequent melting process. But first, the individual compacts have to be welded together. What looks like a submarine is in fact the welding chamber, the so-called plasma welding line. When the hatch is closed, pumps extract the air from the chamber. Oxygen and nitrogen would otherwise make the welds brittle. This is a welder's shield. It's needed to protect your eyes against the harsh light. Here we see how the arc melts the titanium. A melting technician monitors the welding process with video cameras. 3 electric arcs burn their way into the titanium surface. After 8 hours, the electrode emerges from the chamber and the technician re-examines the welds. The electrode is ready for the melting operation proper. This is the centerpiece of titanium production. An electric arc heats the metal to 1650 degrees Celsius in a high vacuum furnace. The titanium electrode goes into the so-called arc furnace up to 3 times. Here we have the opened vacuum melting furnace. There we see the top of the furnace and the electrode rod with the contact flange that connects via the stub to the previously melted ingot. An arc is then struck with the ingot at the bottom of the crucible several meters further down, and the ingot melts from the bottom to the top. The workers place various additives in the bottom of the crucible to prevent the titanium ingot from welding to the furnace. The technician then cleans the edge of the crucible. The electric arc furnace operates in a vacuum with only millionths of normal atmospheric pressure. Even a hair on the crucible sealing surface would kill the vacuum and allow oxygen and nitrogen to enter the furnace atmosphere. Final preparations. The titanium ingot moves into the electric arc furnace. Huge pumps create the high vacuum. The actual melting operation begins. For safety reasons, nobody must get too close to the furnace. A 30,000 amp electric arc heats the titanium ingot until it begins to melt. After 10 hours, the operators remove the top of the furnace. The crucible has cooled down slightly on the outside, but it is still extremely hot in there. The men carefully withdraw the crucible from the furnace. The titanium ingot inside weighs 7.5 tons. An operator releases the floor plate. The birth of the high-tech metal. The magnesium contained in the raw titanium reacts with the oxygen in the incoming air and combusts. The titanium ingot has to cool completely before it can be further processed. The next step. The ingot is placed in a large lathe where its contaminated surface is removed bit by bit. The ingots are then taken to the forging shop and reheated. The titanium can now be processed like any other metal. Huge pressure of 1,600 tons makes the red-hot titanium ingot pliable. A technician continuously monitors the temperature of the metal. The ingots are taken back and forth between the furnace and the anvil. The total forging operation can take up to 2 days. The titanium is not ready yet. The ingots are placed in the lathe a final time to get them to exactly the right size. Titanium, the high-tech metal, is ready for further processing in industry.